Hey everyone, and welcome to this explainer. Every single year, the world generates over 2 billion tons of municipal solid waste. That's massive. And today, we're shining a spotlight on the true unsung heroes of the modern circular economy, waste management companies. It's so easy to get caught up in flashy new tech or sleek electric vehicles when we talk about sustainability, right? But honestly, the absolute foundation of a truly sustainable future relies entirely on how we handle the things we throw away. So we're going to decode the exact metrics used to measure all this, specifically diving into the SASB recycling and resource recovery standards. It's a genuinely fascinating look at the actual accounting behind sustainability. Let's get right into it.
Okay, let's dive into this roadmap. 1. The Resource Recovery Framework. 2. Tracking incinerated waste. 3. Measuring recycling and composting. 4. Accounting for electronic waste. And 5. Driving the circular economy. So what we have here is our master blueprint, the SASB IFWM 420 standard. It's a bit of a mouthful, I know, but this framework outlines exactly how companies in the waste management sector are required to measure their landfill diversion and resource recovery efforts. It basically takes these massive, complex global operations and breaks them down into specific, standardized, quantitative metrics.
Think of the SASB standards as the universal ruler for environmental impact. You know the old business adage, right? You literally cannot manage what you do not measure. By establishing this ruler, the standard gives investors, regulators, and the companies themselves clear, totally comparable data. It removes the guesswork, and more importantly, it cuts right through the greenwashing, replacing vague claims of being green with hard metric ton data on exactly where all that waste is actually ending up.
Let's start with Section 1, Tracking Incinerated Waste, Measuring the Burn.
Now, to accurately account for this, we first need a strict definition. The standard defines incineration as the controlled process where combustible solid, liquid, or gaseous wastes are burned and changed into non-combustible gases. It's absolutely vital to set this baseline, because in environmental accounting, definitions dictate the data. We're not just talking about throwing trash in a bonfire here. This is a highly specific, controlled industrial process.
So the crucial point is how all of this actually gets reported. Companies have to disclose 3 exact requirements. First up, the total weight of waste incinerated, measured in metric tons. And keep in mind, this includes both solid and hazardous materials. Second, they've got to break out the percentage of that total weight that is hazardous waste. And third, they need to report the percentage of that incinerated waste that is actually used for energy recovery.
Which naturally begs the question, what exactly counts as energy recovery? While the standard is crystal clear on this, energy recovery is defined as using combustible waste to generate energy through direct incineration with or without other waste, but specifically with the recovery of heat. If you're just burning waste to reduce its volume without capturing the heat to generate usable energy, that doesn't count toward your energy recovery percentage. Precision here is literally everything.
Moving on to Section 2, Measuring Recycling and Composting, the core of the circular economy.
Under this standard, companies must report absolute weights, again, in metric tons, for 3 distinct material recovery streams. They have to report the weight of material recycled, the weight of material composted, and the weight of material processed as waste to energy, or WTE for short. By separating these into 3 distinct buckets, analysts can see exactly what kind of recovery infrastructure a waste management company is actually using on the ground.
Let's take a closer look at composting. The standard defines compost as the product resulting from the controlled biological decomposition of organic material, which is sanitized through the generation of heat and stabilized so it's beneficial to plant growth. The absolute keyword here is controlled. This strict definition exclusively excludes the natural, uncontrolled decay of organic solid waste, meaning you can't just leave organic waste in a pile to rot in a field and count it as composted material under this standard.
Now, what's really interesting about this is how the SASB standard draws a strict distinction between recycled material and waste to energy. While both are ways to divert waste from a landfill, they're fundamentally different processes with totally different environmental impacts. Recycling keeps the material in the physical supply chain as an ingredient or a substitute for commercial products. Waste to energy, on the other hand, converts non-recyclable materials into usable heat, electricity, or fuel. Because of this difference, the standard outlines a really crucial exclusion. Waste to energy must be strictly excluded from the scope of recycled material. This is a massive guardrail against greenwashing. A company absolutely cannot burn waste, capture the energy, and then turn around and boast to the public or investors that they recycled that material.
Burning waste for heat or electricity simply does not count as recycling under this accounting framework. They have to be tracked and reported in their own completely separate lanes.
All right, Section 3, Accounting for Electronic Waste, Managing the Digital Footprint.
As our entire world digitizes, e-waste has easily become the fastest growing and, honestly, one of the most complex waste streams globally. The standard sets a very clear boundary for what qualifies. It includes waste from electronic products, so think computers, televisions, mobile phones, stereos, copiers, fax machines, the whole shebang. These items are incredibly resource-dense. I mean, there's often more gold in a ton of smartphones than in a ton of actual gold ore. It's crazy. But they also frequently contain hazardous materials, which makes their proper tracking and recovery absolutely essential.
And this brilliantly illustrates how the standard requires a two-step accountability process for e-waste. First, in Step 1, a company must track the absolute weight of all the e-waste they collect, measured in metric tons. But look, collection is only half the battle, right? In Step 2, they have to report the exact percentage by weight of the materials from that e-waste that was actually recovered through recycling. It forces companies to prove not just what they took in, but what they successfully processed and put back into the supply chain.
Which brings us to Section 4, Driving the Circular Economy, from Waste to Revenue.
Let's look at how all this data builds into a really powerful business case for resource recovery. The whole industry is facing a massive paradigm shift right now. We're seeing a huge push for decreasing landfilled waste and a rapidly expanding recycling market. Cradle-to-cradle approaches, where products are literally designed to be infinitely recycled, they can only succeed if waste management companies have the actual recovery infrastructure in place. By meticulously tracking these metrics, companies can prove they're meeting changing consumer and regulatory demands, ultimately positioning themselves for massive revenue growth. They aren't just taking out the trash anymore, folks. They are the suppliers of tomorrow's raw materials.
Which leaves us with this final, somewhat provocative thought. Is your resource recovery data ready for the circular economy? The SASB framework we've unpacked today isn't just a compliance exercise. It's a competitive advantage. If you don't have this level of granularity, separating recycling from waste to energy, tracking the specific recovery rates of e-waste, precisely measuring the energy recovered from incineration, you are kind of flying blind in an industry that is evolving at lightning speed. Thank you so much for joining me for this explainer. I hope this deep dive has helped decode exactly how we measure the future of resource recovery. Catch you next time.